Right, in this little episode I want to deal with what I've dubbed an exotic integral, the integral concerned being the integral of the cube root of tan x dx. In a previous video I dealt with the square root of tan x dx integrated. Paradoxically, this particular integral is a bit easier than the one for the square root, just using basic methods. So there is nothing exotic about the actual working out of this. So what I've done is to make u cubed equal tan x, which means that 3u squared du equals sec squared x dx, which is 1 plus u to the 6th dx, and the integral transforms to this integral here, which is the integral of u times 3u squared du over 1 plus u to the 6th, which on the next step I've factorized the bottom. The top is 3u cubed du, and the denominator is 1 plus u squared times 1 minus u squared plus u to the 4th, which by the use of partial fractions comes down to these integrals which I've numbered 1 and 2, the first one being the integral of u cubed plus u over 1 minus u squared plus u to the 4th, and the second one is minus u over 1 plus u squared du. So I'll deal with the first one first, number 1, and I've written it as 1/4 4u cubed plus 4u over 1 minus u squared plus u to the 4th, which is 1/4 integral 4u cubed minus 2u plus 6u over 1 minus u squared plus u to the 4th, which I've then split up as 1/4 of the integral 4u cubed minus 2u over 1 plus u squared plus u to the 4th plus 6 over 4 u du over 1 minus u squared plus u to the 4th. Well, the first of those, well, the top is now the exact differential of the bottom, which was the purpose of all that manipulation, comes down to 1/4 log to base c 1 minus u squared plus u to the 4th, and we've still got one more integral to do, which is 3 over 2 u du over 1 minus u squared plus u to the 4th. I've had to resort to another substitution here, so I've let z equals u squared, and that last integral will then transform to 3 over 2 integral dz over 2 into 1 minus z plus z squared, which is 3/4 dz, and then I've completed the square on the denominator, so we get, that ends up with 3/4, because that's a standard integral, 3/4 2 root 3 tan inverse 2z minus 1 over 3. It reverts to square root 3 over 2 tan inverse 2u squared minus 1 over 3, because we let z equal u squared. Now, the second of those integrals is this one here, u squared, u over 1 plus u squared du, which is 1/2 2u du over 1 plus u squared, and that easily integrates because the top is the exact differential of the bottom to 1/2 log 1 plus u squared. Collecting all our results, we've got, come down to this line here, which is 1/4 log to base e 1 minus u squared plus u to the 4th plus square root of 3 over 2 inverse tan 2u squared minus 1 over square root of 3, and minus log to base e of 1 plus u squared. So that takes us that far. And then what I've done is amalgamated the two logarithmic terms to give 1 over 4 log 1 minus u squared plus u to the 4th over 1 plus 2u squared plus u to the 4th plus square root 3 over 1, 2 inverse tan 2u squared minus 1 over root 3. Now, our original variable was x. So, reverting to that original variable, we've got our old integral, which is the cube root of tan x dx, is 1/4 log e 1 minus tan x to the power 2 upon 3 plus tan x to the power 4 upon 3, all divided by 1 plus 2 tan x to the power 2 upon 3 plus tan x to the power 4 upon 3 plus square root 3 upon 2 inverse tan 2 tan x to the power 2/3 minus 1 divided by square root of 3 and our little constant on the end there. And that completes it. Thank you for listening.